Remember from our last chapter section, we said the limit of absolute value of 2x over 2x. Now, we just had x and x, but I could put a 2 there if I want. As x approaches 0 was undefined. We had a limit that does not exist. Graphically, if you look at this, you can see that if we look at the limit as x approaches from the left, we had something that looked like this. And if we looked from the right, we had something that looked like this. Now, here was our y value of 1, and then 2, and then 1 and 2. So we said that the limit does not exist. We're looking at as x approaches 0 from the right and x approaches 0 from the left. The trains are going into different stations. So if you are looking for the limit right here at x equals 0, then you'd have to say the limit does not exist. We don't have a trend in y. Why can't we find the limit? Well, if I took the limit as x approaches 0 from the right of f of x, which is 2x absolute value over x, where is y heading? Y is heading towards 2. That's plus 2. And if I take the limit as x approaches 0 from the left, that's down here, of 2x over 2x, I get negative 2. Because the right-hand limit does not equal the left-hand limit, we have to say the limit does not exist. This is the idea of a one-sided limit. In our first section, 11.1, you saw that one way in which a limit can fail to exist is when a function approaches different values from the left side of C than what it approaches from the right side of C. That's when we said the trains are going into different stations. This type of behavior can be described more concisely with the concept of one-sided limits. Look, the limit as x approaches C from the left, that means a little bit less, is some value, L1. In our previous example, it would be negative 2 from the left. And the limit as x approaches C from the right is some other limit, L2. That's the limit from the right. So in total, you'd have to say that the limit as x approaches C, this means from both sides of f of x, does not exist. Why? Because the limit from the left does not equal the limit from the right. Both of the limits must be going towards the same y value. Otherwise, you don't have a trend in y. Finding one-sided limits. The question asks us to find the limit of f of x as x approaches 1. And hopefully you recognize this as a piecewise function. It tells us that f of x is equal to negative x plus 4 when x is less than 1. So if we're graphing that, take a look at what this looks like. Negative x plus 4 when x is less than 1. We know that the slope is negative 1 over 1 and the y-intercept is 4. And x equals 1 is right there. So our graph will look something like this, going on and on forever as long as x is less than 1. That's what our graph is defined as. Now, x is negative x squared plus 4x for x is greater than 1. X is less than 1, x is greater than 1. Clearly, when x equals 1, our graph will be undefined. If we graph this particular graph, we're going to get something that looks like this. And if you found the x-intercept of this by substituting in a 0 for y, you'd see that the x-intercept is over here at 4, 0. So I know the graph looks something like that. And its maximum point, well, how do I know anything about y equals negative x squared plus 4x? I do know that the axis of symmetry will be found at negative b over 2a. So that is our b, negative 4 over 2 times negative 1, which gives me x equals 2. At 2, I get 2 times 4 is 8 minus 4 is 4. So I know that this point here is my maximum, 2, 4. I did that all with simple Algebra 1 techniques, finding my axis of symmetry, then finding the function value of the axis of symmetry to get my maximum point. So I can draw a quick, accurate graph of both of these like this. Now, what I'm going to do is I'm going to look at the limit of f of x as x approaches 1 from the left. I'm going to find the one-sided limit. Look what's happening to y as we squeeze in. I'll do it in a different color. As we squeeze in on x equals 1, this is x approaching 1 from the left. Positive 1, a little bit less. So we're squeezing in this way. Y is heading towards, well, y is heading towards a 1, a 2, a 3. Y is heading towards 3. I'm also going to find the limit, the one-sided limit, as x approaches 1 from the right of this function f of x. So what am I looking at there? As x squeezes in on 1, this is x is squeezing in on 1 from the right. What's happening to y? Well, if you use your trace feature of your calculator, you'll see that as x approaches 1 from the right, numbers like 1.03, 1.02, 1.01, the y values are also going to 3. So our left-hand limit is equal to our right-hand limit, which allows us to conclude that the limit as x approaches 1 from both sides of f of x is 3. Why? Because the left-hand limit was equal to the right-hand limit. Let's consider another piecewise function where we're asked to find the limit, and we can break the limits up to left-hand limit and right-hand limit and see if they agree with each other. If I'm given the limit of f of x as x approaches 3 of this piecewise function that says that f of x is equal to negative x minus 1 if x is less than 3, there's our line right there. Notice I have an open circle here at, this would be the point 3, negative 4. If I substitute in a 3, I'll get negative 4 for my y value. I have an open circle because x is less than 3. But the square root function, we know that looks like a swimmer coming out of the water, but moved 3 to the right and 2 up. So here is the point 3, 2. And notice I put a darkened circle there because x is greater than or equal to 3. Now, let's consider the one-sided limits. The limit as x approaches 3 from the left of f of x. Well, we're looking for the trend in y as x approaches 3 from the left. In other words, x is negative 1, 0, 1, 2, 2.5, 2.9, 2.99. As x gets closer and closer to 3, where is y heading? You guessed it, y is heading towards negative 4. How about the right-hand limit? We take the limit of f of x as x approaches 3 from the right. Well, now we're coming this way. We're squeezing in on 3. Here is 5, then 4, then 4.1, then 4.01, then 4.001. Where is y heading? Hopefully you guessed it, 2. Now, the left-hand limit does not equal the right-hand limit. The trains are going into different stations. So we'd have to say the limit does not exist. Why? The left-hand limit is not equal to the right-hand limit. They're not going to the same y. There's no definite trend in y.